The consequences of climate change are highly complex and challenging to predict, even more so when coupled with rapid and uncertain socio-economic change. Assessing the impact of long-term decisions about how we respond to climate change is therefore very difficult, especially as such decisions are vulnerable to unforeseen tipping points, irreversible thresholds, disturbances and shocks that can undermine even the most carefully crafted policies. Conventional approaches don't work for assessing high-end climate change scenarios, and so the Impressions project has pioneered alternative approaches. Instead of trying to develop a clear-cut bottom line or optimal policy, which is inevitably going to be unrealistic in the face of such uncertainty, the project has instead focused on aiding the process of understanding the possible consequences of climate and socio-economic change and developing robust, achievable options for dealing with them. To help tackle this challenge, the Impressions team developed a multiscale modelling framework capable of combining many different simulations to explore the impacts of high-end climate change on multiple sectors at different geographic scales. This multiscalar approach is important because, for example, it allows the outputs of higher-scale models, such as those at global or European level, to be fed into lower-scale models. For example, using trade flows at the global level to provide a basis for understanding food imports to Europe, or using human migration patterns at European level to provide insights into population growth at the national or subnational level. The multi-sector approach is important because it takes account of interactions between different sectors such as agriculture, forestry, and biodiversity as they compete for resources such as land, water, and energy. This allows exploration of synergies and trade-offs between adaptation and mitigation actions. For example, the potential for tree planting to alleviate flooding as well as storing carbon. The Impressions modelling framework has been used to explore the consequences of the future scenarios for each of the case studies in Hungary, Iberia, Scotland, Europe, and Central Asia. Here are some of the projected impacts resulting from the models. Firstly, average temperatures are projected to increase under all scenarios. Even the moderate climate scenarios suggest an average temperature rise of 3 degrees Celsius, with a 3% increase in annual precipitation in Europe as a whole. In scenarios where greenhouse gas emissions are higher, the changes are more dramatic. By the end of the 21st century, average temperature increases to a staggering 5.4 degrees Celsius, with a 5% increase in annual precipitation. But in all scenarios, these averages mask large differences across seasons and regions. At the extremes, the Mediterranean and Alpine regions are projected to experience a warming of more than 8 degrees in summer, with steep decreases in precipitation across southern Europe, dropping by as much as 60% in Iberia. The implications for water management under such conditions are significant. Efficient water use technologies and water-saving behaviour can reduce vulnerability to water stress in some scenarios. Even so, modelling projects severe water scarcity in southern regions of Europe, resulting in reduced agricultural and forest productivity. By contrast, northern Europe could experience a boost in agriculture and forestry due to longer growing seasons. Flooding is projected to increase across Europe, especially in coastal areas, with an extra 17 million people being affected by a 1 in 100-year flood event in the 2080s under a high-emissions scenario. Impacts on biodiversity are severe, with many species projected to lose substantial areas of suitable habitat due to climate change, including the capercaillie and the lynx. Some species are projected to increase their range in parts of Europe, but only if they are able to migrate northwards quickly enough. Human health is projected to be severely affected by high levels of climate change, with tens of thousands more deaths per year from heat stress in southern and eastern Europe. Modelling also projects a rise in Lyme disease infection rates across all scenarios in both Hungary and Scotland, as tick habitat expands in a warmer climate. This has more important implications for outdoor recreation, tourism and healthcare in both countries, which will require habitat management, adaptive disease strategies, and public information campaigns to help cope with the problem. The multi-sector modelling framework highlights the complex interrelationships and trade-offs between urban development, agriculture, forestry, water resources, and biodiversity. For example, in a sustainability scenario, an environmentally driven shift to less intensive agriculture or a focus on reducing food imports is projected to lead to expansion of agricultural land in Europe at the expense of forests. This could cause biodiversity loss and increased water stress due to higher demands for irrigation. Low meat diets can free up agricultural land, but this could be offset by an increase in dairy consumption. By contrast, in a resource-intensive scenario with high productivity due to inputs such as fertilizers, intensive agriculture is projected to concentrate in the most productive areas in Northern and Western Europe. Land is available for reforestation in other regions, but this is limited by high levels of urban sprawl, which has negative impacts on biodiversity and ecosystem services. These and other combinations of climatic and socio-economic scenarios will have an important influence on land use change, and appropriate land use policies will be needed to address such challenges effectively. It is in helping to understand such complex relationships where the impressions modelling framework stands apart from conventional approaches. And by responding to these results with positive visions developed with stakeholders, where the project has developed transition pathways and transformative solutions towards a more sustainable future. Keep watching to find out more.